should never go, since it's bounded above and this thing it's increasing, right? So its limit should not surpass 6, but they haven't really proved that it should be equal to 6. So indeed, I'm guessing here that's where they prove it's equal to 6.
Indeed.
That part where you go to that part where you said you didn't understand. Where you said that you didn't understand. Okay. Now you see there they preempted themselves. They stated that and then they proved it.
They proved, okay.
Yeah, so they shouldn't. Well, they can state it and then prove it, but the confusion part is now they said something and then proved it later.
What if it was wrong?
We accept simply bounded. So let's just assume they didn't even use a 6. They used any bound. Monotone convergence will apply just as well. For example, they used an 8, right? You agree that monotone convergence will work just as well with a bound of an 8?
Yes.
Okay. Now go back to that that bit that we.
This part.
Yes. So we agree that the limit is less or equal to some bound. Now look at where they start from indeed. So indeed, you have the definition, right? You take the limit both sides, and then on the on the right hand side, you just use properties of the limit, you push it into the brackets, right? Yeah, and then you use the fact that the limit of an is the same as the limit of an plus 1, right? And we just decide to call it L, right?
Yeah.
And now the definition gave us an equation 2L equals L plus 6. And then we just solve for L. So the first 6 is really, it doesn't matter that it's a 6, because it's really to establish boundedness. As long as it's some high number above 6, that limit should work. That boundedness should work. And then the limit from the indeed, that proof depends purely on the definition. It doesn't depend on what you said about the boundedness or anything like that. So even if you didn't bound it with a 6 and maybe were very conservative and you decided to bound it with something bigger like a 10, it would actually, when you're working out the limit, it would work out as 6.
Oh.
Yeah. I mean, try the induction on the boundedness part with a larger number than 6. Then carry on. Just carry on with that and then see what happens. It won't affect your limit. But it will give you what you want, which was specifically the boundedness bit. Okay, and then go up a bit.
Up.
Yes. Up. And why did they suspect this was bounded above by 6? It's mainly because, I mean, when they, the first part of the solution, when they computed the first few terms, you notice we jump up from 2 all the way to 4 to 5, and then we go into 5.5. If you ran it maybe a few more times, you'll notice that it might struggle to hit above 6, and then you might, 6 might be the limit here, because they're saying find the limit, so there probably is a limit, and you're just writing up the terms and you seem to be struggling to jump above 6. So 6 might be a bound. and that's where you had the suspect of 6 being a bound. But then the proof of the limit just so happens 6 is in fact the limit.